Hello everyone, just getting started. Take a second. If you're seeing this later, you can probably click on the next chapter, because this is me taking forever each time. There's probably some way to do this, like where I can preset up all the chat and everything beforehand. Alright, I think we look good. I started, but I have no idea what to work on. Alright, what do we feel like? We have... We can learn some Haskell, some more Atari, some COBOL, some Nix, some Rust. I'm thinking Rust. I feel like I haven't done Rust in a while. And there's some Elixir Phoenix Live View. We can do some more Gleam. Alright, let's take a look at... Rust. So we'll set that up. I'm so tired today. I'm so sorry. Like, and all my friends were saying like, oh, I'm so tired today too. So I feel like today's some kind of like, maybe last week was just long and hard. Or maybe it's just that Christmas is coming and we're like trying to rush for everything. Alright, let's bring up Rust. Let me figure out how to do this. We'll switch over here. Yeah, we're not quite set up, are we? We'll go to the Rust website. And someone mentioned to me that I just didn't see it. There's this book version here. There's this book version. But then when you do the book, I think if I click the book, then there's an option to do like a version with quizzes. Oh, here, want a more... It's funny because I think the first time I read all of this, but then I just didn't read like this. This looks like tips or something, so it's not worth like clicking on. Want a more interactive learning experience? Try out a different version of the Rust book featuring quizzes, highlighting visualizations, and more. I wonder if it's the same version. Let's check it out. Experiment. Improving the Rust book. What is this? The website is an experiment with the Cognitive Engineering Lab at Brown University. The goal of this experiment is to evaluate and improve the content of the Rust book to help people learn Rust more effectively. Alright, how does it work? This website has the same structure as the Rust book, but modified in two ways. Interactive quizzes are added in each section. These quizzes help you test your understanding of Rust. The quizzes also help us determine which sections need improvement. Some explanations will be changed. For instance, we will experiment with modifying some of the text, including replacing it with visualizations. Do I have to participate? No, you're not obliged to do so. Participation is entirely optional and you may stop using this version anytime. Alright, so what data? There's nothing personal. We register what you do, record what you do on the quiz, and other stuff about your answers. Alright, well that sounds fine. If x is 0, what will happen when computing? It's not like where you type in code, which I think I would have preferred. Let's see what happens here. Experiment Introduction. Welcome to the Rust Book experiment and thank you for your participation. First, we want to introduce you to the new mechanics of this experiment. Quizzes. The main mechanism is quizzes. Each page has a few quizzes about the page's content. We have 2 rules about quizzes for this experiment. Take a quiz as soon as you get it. Do not skip a quiz. Alright. The quiz looks like the one below. Try it out by clicking Start. Question, what is 1 plus 1? Try clicking a wrong answer. Review. You answered incorrect. You can retry the quiz. Okay. They say it twice. Retry the quiz. It's 2. Oh, they don't make it so that you can... Oh yeah, you can click anywhere. Correct. See Principia Mathematica for an explanation of this fact. That's going to take a little bit longer, isn't it? Okay. If you get a question incorrect, you can choose to either retry the quiz or see the correct answers. We encourage you to retry the quiz until you get 100%. Alright. Another mechanic is highlighting. You can select any piece of text and either highlight it or leave a comment about it. Once you select some text, click the pencil button and leave an optional comment. Try highlighting this text. Okay, now I can click this. Your note. I'm trying it. You can use highlights to save information for yourself. You can also use highlights to give us feedback. For example, if you think a section of content is confusing, you can let us know. And there, it's over here. And I guess I can delete this. Yeah. Note, your highlights will disappear if we change the content that you've highlighted. Also, your highlights are stored as a cookie. That's kind of funny that they put everything in a cookie. I think a single cookie can only hold like 4K, right? If you block cookies or change browsers, then you won't see your previous highlights. 3. And more. The book's contents may change as you go through the experiment. We'll update this page as we add new features. Here's the change log. Alright, so they've done stuff as recently as September. Thus far, this experiment has led to 2 open access publications. Check them out if you're interested. Cool. It's funded by Amazon Web Services and Nico Matsakis. So here we are like starting the actual book. It assumes you're using Rust 1.8.0 or later. Run Rust C version to see your Rust version. Let's try that out. I need to bring up my WES term. Let me get that on the screen for you all. Let's see here. There it is. Let's make this a little more reasonable here. We'll move the browser to the right. We'll kind of make it smaller.
No.
And I will be much smaller too. And the WES term here, needs to be a little thinner.
What? Oh.
Maybe that's not good. Well, we'll stick with this for now.
Non, c'est j'en perds plus qu'autre chose. Bon, allez, ciao.
So what it wanted us to do was check which version of Rust we have. I don't think I have Rust. Rust C. So let's install it. I use NixOS, so I'm going to type in NixOS, package search. I forget. We're going to get Rust. Rust C, Rust up. Let's see what happens if I just type Rust. Rust C. So we will do Nix. We'll go into projects. We did something in Rust before, right? Ah, we have shell Nix. Rust up. Let's see what happens when I run that. That should get me Rust. How is everyone doing? Yeah, really low energy for me today. Sorry about that.
Non, c'est juste marqué obtenir un jour de paix en faisant un bus avec la pub Chinatown sur un itinéraire entre les quartiers Oakwood, West Oakwood et Islander Park. Là, il y a West Oakwood.
It's downloading the channel probably, so it has to download all the Nix packages.
Oakwood, c'est là. Donc c'est un itinéraire qui fait ça.
If you're interested in Nix, check out my videos playlist on Nix. I have a whole bunch there. Alright, so looks like what? Copying. So does that mean we have Rust C now? We do. And what did we need here? We needed Rust 181 and we are 185. So we're good to go. This version of the text assumes this, right? HTML is available and offline. Rust. Open the book, several, this paperback. So I think I can just click next. It wasn't always clear. So we did this. I have a Rust video that I did where we just did the very beginning. So we're going to skip this, except we're going to do the quizzes. Code does not compile, code is panicking, and this does not produce the desired behavior. So it looks like code doesn't compile. He's like, huh? And then the code panics. He's like, ah. And then code doesn't provide is sort of like, I don't know what this hand thing he does here. Okay. Let's get started. Installing Rust. Write a program that prints hello world. Use cargo. First step is to install Rust. I think we did that. Rust up update if we needed to update Rust. Okay, here we got a quiz. The installation of Rust also includes a copy of the documentation so that you can read it offline. Run rust up doc to open the local documentation. All right, here we go. What is the name of the command tool for managing the version of Rust on your machine? I think it's rust up. Correct. All right, we're doing well. Hello world, now that you've installed Rust, it's time to write your first Rust program. We're going to do hello world. Let's make a new Rust directory here. I'll make a temp. And I'll just move everything I'll just move hello cargo, hello star into temp. That way we can kind of redo this without screwing anything up. Make directory hello world. Is that coming through? Yeah, you guys see that. You guys see this too? I think so. God, Windows is so ugly with all these things. Writing and running a Rust program. Make a new source file and call it main.rs. So let's make something called main.rs. And I like to type things in because it kind of helps me remember stuff. Print line hello world. And we need semicolons in Rust. Now we save this program. And we do what? Save it, go back to your terminal window, and enter rustc main.rs. And then we can run main, and it says hello world. Awesome. Anatomy of a Rust program. Yeah, I think we get this part. There's a main function. Same thing when we're doing Gleam yesterday. It looked like pub fn main, so it looks very similar. In fact, it's probably here, right? Gleam. Oh no, I didn't write it. We wrote it all in the browser. Okay. The function body is wrapped in curly braces. Okay. The body of the main function holds the following code. Hello world. The Rust style is to indent with 4 spaces, not a tab. Print line exclamation point calls a Rust macro. If it had called a function instead, it would be entered as print line without the bang. So we'll learn more about that later. We learned about the Rust C compiler. I guess that's just Rust compiler, Rust C. And okay, what is all this? 2 files. We have main.rs and main. Yep. The source code has the rs and the executable is main. Such as, if you're more familiar with dynamic languages such as Ruby, Python, and JavaScript, you might not be used to compiling and running a program. Yeah, we did all this. Let's take the quiz. Every executable Rust program must contain a function with the name main. Let's say you have the following program in a file, hello.rs, main, Say you then run the command rustc hello.rs from the command line. Which statement best describes what happens next? Rustc generates binary executable named hello, executes the program and prints out hello world, reformats hello rs according to the Rust style guide, print an error because it is an invalid program. So you have a program hello.rs and then you run rustc hello rs. Then it's going to just generate a binary named hello. Okay, good. Doesn't give us like any extra feedback. I think I like these quizzes, right? They're like good things to add on to. Hello cargo. Okay, so now cargo is the packaging manager. Well, it's the build system too, right? So let's go and type what they said earlier, what they say here, cargo version. And we have the same version as Rust C, right? Yeah, it's the same exact version, except it has a different like git commit or something like that. Creating a project with cargo, we just type in cargo, new, hello cargo. Then we can go into hello cargo. And inside of hello cargo, we should see a cargo dot. I remember how to pronounce this in the last video. I asked myself, Toml? I think it's Toml, because I was saying Toml, but I learned it wasn't that. Alright, so now we're going to edit cargo Toml, and it has the package heading. Then under package we have name, hello cargo, version, and edition. And then we have a bunch of dependencies. Tom's obvious minimal language. The first line package is a section heading indicates that the following statements are configuring a package. Yeah, so that's cool. And then the last line dependencies is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. So crates are like, maybe they're a little bit bigger than modules. They're like whole things that compile, I don't know, libraries, I guess. We won't need any other crates for this project, but we will in the first project in chapter 2, so we'll use this dependencies section then. Now open source main.rs and take a look. Source main.rs, here we go. It put in the same hello world that we wrote before by default. Cargo has generated a hello world program for you, just like the one we wrote. Yep. Cargo placed the code in the source directory, and we have a cargo toml configuration file in the top directory, right? So we have cargo on the top, and then under source we have main.rs. Cargo expects your source files to live inside the source directories, the top level project directories, just for readme, license, configuration, and stuff that's not related to code. Alright. Build and running a cargo project. Now let's look at what's different when we build and run Hello World program with cargo. From your Hello Cargo directory, build your project by entering the following command, cargo build. Alright, it's building for us and it finished. This command creates an executable file in target debug hello cargo. Target debug hello cargo. I see, that's the actual executable. And if I run that, it says hello world. And that's what we just typed here. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo lock. So we see a cargo lock. Let's open that file up. And it says it's automatically generated by cargo. It's not intended for manual editing. Alright. So we won't touch that one. This file keeps track of exact versions of dependencies in your project. This project doesn't have dependencies, so this file is a bit sparse. Don't change it manually. So we just built with cargo build and ran it with target debug hello cargo, but we can also use cargo run to compile the code and then run the resultant executable. There we go. So it checks if it needs to build. It didn't really, and then it just ran it. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. So most developers use cargo run. Hello, Negvorsa. You were there, I think we've met before, right? Negvorsa on Twitch. What time machine did you use? Why? What happened? What's going on? Why do you say that? Um, where are we here? Cargo also provides a command called cargo check. This quickly checks your code to make sure it compiles, but doesn't produce a executable. Yep, so it doesn't build it. From dinosaur era books to modern. That is true. We were looking at I was just looking at the Max 65 DDT manual just earlier. Let me see if I can move this over. Huh? No, but no one sees it. Because what we see is over here. Oh, there is chat. You guys can see chat. Oh, okay, let me move this. Where does this go? Oh my. I don't know where to put this because it's like you can't read it anywhere. I have nowhere to put it. I should change the color of the font. That's what I should do. You think I can do that now? Text color, white. I wonder if I can just change it to like green. What happened? It didn't like that. Now I can't see anything. Huh? Oh, now it's really not happy. What?
Reset.
What do you mean reset?
I don't know.
I'm really bad at all this chat stuff. Refresh cache of current page. Oh well, I lost you. I will try to fix it later. But I can read. Check YouTube too. I put message and you didn't. Oh no! Yes, someone's whispering. Hello Jester. I see your message on YouTube too. I'm doing well. We were just talking about how yesterday we were doing dinosaur programming and today we're doing Rust, and that's just how we roll, I think. So sorry if that's difficult, but we like everything. Right, I was just gonna show real quick, like, this text that I was reading. Yeah, this. We were just reading, like, this earlier. I was just reading about the Max 65 user manual because someone on, I think, Mastodon on Fediverse sent me a reference to this. And now this is like basically the cartridge version of the Max 65 assembler for Atari and how to use it in cartridge mode. And I think it also talks about the DDT debugger, which I didn't know how to use. So we'll take a look at this some other time. But yeah, that's basically the dinosaur stuff. Okay, but we're back on the non-dinosaur stuff. What? What? Oh, it doesn't matter. Apparently I have a typo in the title. It's okay. Did you hear about Devin? No, what's Devin? What are you talking about? I will learn as soon as I am MERN stack with mobile dev too, so I am still learning. Devin is junior developer AI. Oh no, I don't know about that. Alright. We're back here. Why would you want to do a check? You just want to see if it's syntactically valid or whatever, but you don't need to create the executable. So we learned about cargo new, cargo build, cargo run, cargo check, and we learned that it's in the source code directory and that we have a target debug directory where the executable goes. And then when you have your final release, you can do cargo build minus minus release apparently. And this will give it optimizations probably. Yeah. But it's going to take longer to compile. So now when we run this, I'm guessing that it has it in target release hello cargo. That's different than the target debug hello cargo. Those are different executables. Let's actually see if they're different in size. Yeah, so the release version is actually bigger, right? No, it's 440K. Oh yeah, it's much, much smaller. This is like 4 megs. The debug version is like 4 megs, and then the release version is just 440K. Which is funny because when we're talking about the Atari assembly programming, it's like 440K is huge, right? And all it's doing is saying hello world. Even trying to use it as Slack to interact and it change and can update code based on any error or bug issue. Do you think this will take jobs or start a programmer? I think in general AI is yeah, it's a little complicated. I think companies just try to have less developers because of AI. It's not like AI replaces developers 100%, right? So there's that. But I think that junior developers get more affected by it than senior developers because here, I'm just like trying to change this size a little bit because they're getting less people in the company, so they want like to keep a few senior people and then maybe like less junior people because the AI can do a lot more of the junior thing. But then we're going to end up with this weird problem where like there are going to be only senior people and like AI, right? And that's kind of weird. So I think it just makes it harder for junior people to get into it and become senior. So they'll just have to stand out more. And the great thing about being a developer, though, is that you don't need a company to develop. Like, I have side projects, I do things, and you don't really need anyone there to do that. You can just do it yourself. Yeah, and if you're just learning stuff where everyone else knows it, like, hey, I'm a web dev that knows some Java, React, and some maybe Python, it doesn't, yeah, but do you know how to use Kafka? Are you good at Docker? Are you good at virtualization? I don't know, like whatever it is that sets you apart, right? I think that's important. All right, going back to this, cargo as convention. With simple projects, cargo doesn't provide a lot of value over just Rust C, but it will prove its worth as your programs become more intricate. Even though Hello Cargo project is simple, it now uses much of the real-world tooling you'll use in the rest of your Rust career. In fact, to work on any existing project, you can use the following commands to check out code using git, change to that project's directory, and build. Git clone example.org, some project, cd some project, cargo build, which we've learned earlier, right? Let's take a quiz. Say you just downloaded a cargo project and then you run cargo run at the command line. Which statement is not true about what happens next? Okay, so this is true. It builds the project. Cargo run is also gonna build and put it into target debug. Cargo watches for file changes and re-executes the binary on a change. No, it doesn't do that. Cargo executes the project's binary. This is true when you call run. Cargo downloads and builds any dependencies of the project. This is true. So this is the one that is not true. Great. Rust versus Golang. Which one I should learn based on I am web and mobile dev? Well, if you're a mobile dev and you want to build on let's read the summary first, and then we'll answer that. Summary. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust, update to a newer Rust version, open locally install documentation. We did not do that. Write Hello World program using Rust C, and create and run a project using conventions of Cargo. It is time to build a more substantial program. All right, let's do that. So, you know, I don't think it's a choice between Rust versus Golang. I think Golang is a much simpler language to learn. I don't know it, but I've heard it's much simpler to learn. So probably you can be up and running much faster with Golang. And but if you want to be a mobile developer, you have to think about, are you developing native apps, or are you using some kind of like framework that takes like, you know, a web framework like using React or something like that, and just making an application using that. If you want to develop natively, then your choices are going to be more like on Android. On Android, you have the Android ecosystem. It could be Flutter also. Java, right? You have those kind of things. And on the iOS platform, you have Objective-C, which people use less of now, and Swift. And if you're doing games, you have Unity with C# or whatever. But I would think about how much you want to be a mobile, because I think that's going to direct more about how that works out for you. Well then, React Native. Then I think I think if you're a new developer, don't kill yourself with Rust. That's just my thing. This is one of the, usually I do languages where I'm learning where I don't know it at all, but Rust I actually know quite a bit of already. It's just that I haven't used it in a while, so I kind of forgot it. But you know, I want to know it better. But Rust was one of the harder languages to learn, for sure. And I think Go would be a lot easier. So if you're still new, then I think that Go makes a lot of sense. You'd be up and running. You wouldn't be fighting to understand complicated borrow checker stuff and lifetimes. So, but you know, do what you're passionate about. Do what you love. All right. Now we're going to do the guessing game. I'm going to go through this. I think I'm going to try to go through this a little bit faster because we did this in the last video. So let's make a new guessing game. Or did we do this in the last video? I don't even remember. Guessing game. So we do Cargo new guessing game. It says it made a binary application guessing game package. See more Cargo TOML keys and their definitions in here. Okay, so it tells us a lot. Let's get rid of this version of Helix, and now we can see that it has its own Cargo TOML file, which looks a lot like the Hello World one we have, except the name is different. And the main.rs is exactly the same as our Hello World. Can you share that PDF? I think it will help me a lot. Share what PDF? You mean the Atari one? It's not going to help you a lot. I wish it were. Okay, this is not good now. Let's see where we are. We did this already. We have the cargo file. We have the source/main.rs. And now we can do a cargo run, which is going to build it also. And it says hello world. What else is going on? Processing a guess. The first part will ask for user input. We'll check that check that input is in the expected form. To start, we'll allow the player to input a guess. So let's do this into our source file. We need to add standard IO. So this is like importing a library. or a module, I guess. And then instead we're gonna change that hello world to guess the number. Yeah, I did this in the last video for sure. And then we're gonna say print input, please input your guess. Okay, and now let mutable guess equals string new. This is making a new guess variable that is mutable, which means we can actually change its value, and it is initialized to whatever string new returns, which is going to be an empty string, right? Now we're going to read from standard input, which is our keyboard, right? Read line, mutable guess. So we're passing this means we're passing a reference to guess, and it's mutable. It'll tell us a lot more about that later. Expect failed to read line. All right. And now we have print line. You guessed. Oops. This one. This looks like it's basically interpolation. It puts guess where this is. All right. Now it's going to explain it to us line by line. To obtain user input and print, we're going to need to bring in the IO library. So they call it a library. The IO library comes from the standard library known as std. So we do std : IO. Do you play any game? I'm sorry if I'm disturbing you. Yeah, like no, I don't play games. Not anymore. I used to play lots of games. Last game I played was Helldivers 2 for real. But when it comes to playing a game or doing this, I kind of enjoy this more. So right now I'm doing this. By default, Rust has a set of items defined in the standard library that it brings into scope of every program. This is called the prelude. So it has stuff that we can use by default, just like print line, I'm assuming. The fn syntax declares a new function, and the parentheses means that there's no parameters. The curly brace starts the body of the function. That's all. Like if you've seen, I don't know, like C, C++, anything like that, this is very, very similar. Printline is a macro that prints a string to the screen. Okay. That's Helldiver 2 won Best Multiplayer Game Award. I just finished Warhammer 40k Space Marines 2. I really wanted to play that. My friend really enjoys it. I've always wanted to like get into the lore of Warhammer 40k. There's all these books around it, but I just haven't. Everything takes time. It's like committing to a new like series or something, you know? So I haven't done it yet. We'll create a new variable to store the user input like this. Let me try again and get this damn Twitch chat working. Just give me 1 second. Sorry about that. I think this is the thing on how to do it. Add browser. Just gonna try it out once more. Oh, the chat is here. You can see it now, right? No, you can't. Kind of did for a second, didn't you? Properties. Browser. This all looks right. So I don't know why it stopped. Maybe I have to try interacting with it. Nope. Let me delete the whole thing and start over with it. Remove. Add. We're adding a browser. Twitch. And the URL is my channel name. Followed by localhost. And then we're going to make it 400 by 400 or so. And then in the CSS, we put all this stuff. No, we're not seeing it, right? That's really too bad. Let me hide the other stuff. If I hide Nix, me too. Yeah, I don't know why that doesn't work. I swear to God, like for a second it did work. So I'll just leave it up here and maybe it'll like start working again. Okay, so we'll just go back. We'll go back to Rust. Sorry, where was I? Also, Elden Ring 2. Yeah, wow. Someone whispered. Yeah, there's somebody here. Don't worry, it's real. These aren't ghosts. Once I was streaming and then something like dropped behind me and we couldn't find anything. That was spooky. Alright. Next we'll create a variable to store the user input. Am I showing this on my screen? I hope so. Oh, is it working now? Oh, maybe it just needed like for someone to type something, right? Is there a way for me to turn my browser into dark mode? That would help too. Yeah, it's your fault, Jester. Okay, so here we create a new string. Now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create a variable. Here's another example. Let apples equal 5. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. We'll be discussing this concept in detail in Variables Immutability section in Chapter 3. To make a variable mutable, we add mut before the variable name. There we go. Let apples equal 5, immutable. Let mut bananas equal 5. Okay, so what that means here though is that if we did something like let apples equal 5 here, let's just compile this real quick. Cargo build. Oops. Why is it? Oh, we haven't run this yet, that's why. Found dot expected expression. So maybe I typed this in wrong. Oh yeah, probably because it doesn't need a semicolon here. Let's look at it real quick. Yeah, it doesn't need a semicolon because it's a continuation. So now when I run build, it says apples is not used, but I bet even more so if I then do apples is equal to 6, maybe it'll be even more mad. Cannot assign twice to a mutable variable. Yeah. So, and then it says, hey, maybe you should make it mutable. So now if I make this mutable, now it just says we never use it, which at least is legal, right? And then if I probably did this, it doesn't matter. We're going to do this. All right. Now when we build, it works. Yeah, you cannot change variables until you put, unless you put mutable in front of it. Which is good. Like in functional languages, like it, you can't change variables ever, pretty much. And that's one of the bonuses of like that, because when you can change a variable any time, then you're like, oh, I wonder how this got broken. But in a function where you can't change any variables, you look at the function, whatever you get as parameters as your input, that's it. That's like what you're using. Okay, we saw all of this already. Receiving standard input. Okay, let mutable guess. We'll introduce a new variable named guess. The equal sign tells Rust we want to bind something to the variable now. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new. A function that returns a new instance of string. String is a string type provided by the standard library that is growable. That is a growable UTF-8 encoded bit of text. The : syntax in the new line indicates that new is an associated function in the string type. An associated function is a function that's implemented on a type. In this case, string. This new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. That all made sense to me. Hopefully it made sense to you guys too. I think that's 300. No, 400, 300. Okay. In full, the let mute guess equals string : new line has created a new mutable variable that is currently bound to a new empty instance of a string. Whew. All right, receiving input, we have use standard IO. That means that we can now use that. IO standard in, so that comes from this IO that we basically called use on. And there's a function under standard in that is readline. If we hadn't imported the IO library with use standard IO at the beginning of the program, we could still use the function by writing this function as standard IO standard in. The standard in function returns an instance of the standard IO standard in, which is a type that represents a handle to the standard input of your terminal. Right, so it's saying that we could have just basically commented this out. What is that? // and then if we try compiling this, this will fail, right? Because it's like, hey, what is this? So that was on line 10. But if we do standard, basically fully qualify this name, where it's coming from, now this should build, right? Okay. But it's better to probably import it and then just type IO standard in, because that's what a lot of programmers will expect to see if they are a Rust programmer. Can you explain that modules needed to run input and output? Right. This module IO has, this library IO has a lot of things in here that helps you do things like read line and this standard in. This function returns a type called standard in, the same name except it has a capital S. You see here, standard IO standard in. And inside of that type are these associated functions, read line, for example. No, just this function, read line. And we need read line to read from standard input. Let's like basically keyboard input, right? Calls the readline method on the standard input to get input from the user. We're also passing mutable guess as the argument to readline to tell it what string to store the user input in. The full job of readline is to take whatever the user types into standard input and append that into a string without overriding its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. Right, so because it's going to put whatever we type into guess, this needs to be mutable. We're saying that whatever you pass in, we're going to treat it as mutable. And that'll make sure, like, probably we can't do this. If we say guess isn't mutable, right? And then we say, hey, read line, I'm passing you something mutable, this probably will result into a compile error. Here it says, cannot borrow guess as mutable as it is not declared as mutable. You see that? And it says how to fix it, which is to put mutable back in here. All right. The ampersand indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot about those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write ampersand mut guess rather than just ampersand guess to make it immutable. All right, so this means that, like, if we got rid of this, this probably wouldn't work. Because readline expected a mutable reference, but instead it got just a non-reference and non-mutable, immutable. So then it told us, like, what to fix. Because in the definition of readline, it says, I want to get a mutable reference. There we go, and this will compile. So what's the ampersand mute doing there? Right here, it's different from here, right? This is saying that this variable is mutable. So the rest of this, like this function, we can, like, change the value of guess. So I can change this to something else. But then here, readline is saying, readline is a function, and we're going to pass the string that we want it to read the input from and put the actual input value into that string that we're passing it. But we have to be explicit and say, I am passing you guess as mutable, right? Because that means I'm allowing you to change guess. And you can only do that if you declared it as mutable when you created the variable to start with. You can't, like, create a regular immutable guess and then pass it to a function as if it were mutable. The compiler is going to say, no, you can't do that. We actually tried that and we showed that that doesn't work. And then the reference, the ampersand here, is saying, I'm just going to pass a reference rather than copying the string. Imagine if the string had, like, you know, a megabyte of text associated with it. We don't want to copy that megabyte. We're just going to basically we're just going to pass a reference to it and say it's this object here. And really that's a little bit like passing a pointer to a memory address. So that's what's going on over there. Often you can pass, like, things that are fixed size, like this string can get bigger and smaller, right? So often, especially since it can become very big, you want to pass by reference. But when you have something like a single number, then that doesn't matter as much. Because a number is a fixed size, it's going to be like whatever, 64 bits, and it's just as long as an address reference, so a pointer. So it's like basically you're not saving much. Or is it telling that guess is mutable? No, it's not saying guess is mutable. It's saying I mean, sort of it is, but really what it's saying is like, you can treat this as a mutable inside read line. Okay. Where are we? Handling potential failure with result. While we're still working on this line of code, we're now discussing a third line of text, but note that it's still part of a single logical line of code. The next part is this method, expect failed to read line. This could have been written, we could have written this code as IO standard in read line, mutable guess, expect, and then some string. Right, so it just means that here I could have joined this, you know, like this. But like, it's easier to read like this. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other white spaces to help break up long lines when you call a method with the method name syntax. Let's discuss what this line does. Let mute guess equals string. So what new is? Right. So it was saying that here here's the equal sign. So on the right of the equal sign is the value that guess is being bound to, which is the result of calling string new. So you see string new is a function, and new is a function that is in this type string. So basically string has a bunch of functions, and one of them is called new. There's nothing special really about this word new. It's not like part of Rust. It's just that someone wrote this type called string. It's part of the standard library, but you could write something, right, and make a function for it. For new, it's common sort of like paradigm to like call a function new when it creates a new instance of an object. So here it's just creating a new instance of this type string. That's right. It's calling one part new from string. Yeah, I think that's right. I think what you're saying is correct. See, it's saying that this is an associated function that's implemented on a type. So it's saying this function is associated with string, is probably in the same file as string is declared and defined, and it knows how to create a new string. All right, expect. We were here somewhere. As mentioned earlier, readline puts whatever the user enters into the string we pass to it, but it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Yeah, it's kind of interesting. It's like just reading this and having done Gleam yesterday, you can see just like Rust has a lot more to unpack when you're learning something. So I think, yeah, result is a type, and it's an enumeration. So it can be one of like many things. In this case, result can be one of two things. And one of them, I guess they'll talk about it. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK and error. Yeah, those are the two types. Those are the two enumeration types. OK, the OK variant indicates that the operation was successful, and inside OK is the successfully generated value. The error variant means that the operation failed, and error contained information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. If the instance of a result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. So here this is saying this, it's basically doing this left to right, right? So first it's getting the standard input type, and then in standard input is an associated function called readLine. readLine is going to return a result. So this expect is part of result. It's a function that's defined for results. And it's going to basically look at the result and say, if it is an error, then crash and print this out. And if it's okay, is that the other one? Yeah, okay, then it probably just returns that value. Yeah, that's what it says here. If this instance of result is an OK value, expect will take the return value that is OK, that OK is holding, and return just that value so you can use it. In this case, that value is a number of bytes in the user's input. If you don't call expect, the program will compile, but you'll get a warning. readLine, note this result may be an error variant which should be handled on by default. Okay, because this warning type is on by default. Help, use this to ignore the resulting value. Alright, Rust warns that if you haven't used the result value returned from readLine, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling code, but in our case, we just want to crash this program when the problem occurs, so we can use expect. You'll learn more about recovering from errors in chapter 9. Yeah, so we can test this out. If I comment out this line, then it's gonna probably say that error that we just saw, which is like, hey, you didn't check the result. Unused result that must be used. It may be an error variant. Use this to ignore the resulting value. So, but we are actually using it by calling expect, and we will crash if it's an error. What is all this stuff? Oh my. Hold on, I'm just reading something. Sorry, guys. Okay. We're back. You got the book. You really wanted that book. Okay, where are we? Printing values with print line placeholders. Aside from closing curly brackets, there's only one more line to discuss in the code so far. Print line, you guessed, bracket, bracket, guess. This line prints the string that now contains the user input. The double open close curly brackets is a placeholder. Think of them as little crab pincers that hold a value in place. It's so funny because, like, I remember when I was learning in school, like, whenever they use metaphor to teach stuff, I would get so confused because, like, you know, I'm very literal. So when they said, like, oh, the greater than sign was an alligator trying to eat something, I'd be like, wait, alligators? What's going on? So at least with Rust, it's like sticking with the crab metaphor or thematic that they have with Rustation. But yeah, I don't need the thing like that. When printing the value of a variable, the variable name can go inside the curly brackets. When printing the result of evaluating an expression, place empty curly brackets in the format string, then follow the format string with a comma-separated list of expressions to put in each empty curly bracket placeholder in the same order. Printing a variable and the result of an expression in one call to print line would look like this. X equals X and Y plus 2 equals bracket bracket Y plus 2. Hopefully this makes sense. When you just have like a single variable that you want to print, you can put it inside of the curly brackets. But if you have an expression, you're not just printing out Y here. If it was just Y, we could put the Y here inside. But since it's Y plus 2, we can't put Y plus 2 in here. We have to basically just use the open and close and then put it afterwards, after the comma. And this code would print out X equals 5 and Y equals 2. Let's actually try making this code real quick without looking. So we have let X equals whatever, like 2 or something like that, right? Let Y equals 3. Wait, no. Yeah, whatever. And then we do print line. And then we have X is equal to, and then we do the curly brace. We put X in here. And Y is equal to, and if we try to do Y plus 2, this will fail. Right? Oh, it's over here. I didn't see this part. Invalid format string expected close bracket found plus. So it didn't like, it's saying, hey, I just thought you would close right after Y. Alright, so this works. So if I do cargo run, it says X equals 2, Y equals 3. But now if I want to print Y plus 2, I have to put it over here at the very end. And now it says X equals 2, Y equals 5. So that's what that was about. Okay. Let's test the first part of the guessing game. Run it using cargo build. Okay, let's run cargo build. This is because I reintroduced the semicolon back here. Okay, it ran. Run it using cargo run. Okay, cargo run. Please input your guess. You guessed whatever, 1 million or something like that. Hey Ben, how are you? I'm doing the quiz version of this. I don't know who told me. Was it you? Someone told me like, hey, there's a quiz version, and so like just kind of redoing it with the quiz version. There aren't very many quizzes so far. Generating a secret number. We're going to use Rust team does provide a rand crate. So it's not part of the language, but there's a crate with it. So we're going to have to add the crate. That's a secret, Jester. Let me see if I can add YouTube too now. Oops. Doesn't look right. Sort of working. Oops, that's not what I meant to do. I'm really bad at this. Why can't I grab the YouTube chat? Because it's locked. But I don't know where to put this. Jesus. Well, we can't leave this stuff on here. We have to figure it out. someday. But we'll just hide all chats, make it fair. I don't think it was me, but this does seem like a pretty good guide. It's also something called rustlings. I think that's more getting used to the syntax and borrow checker rules. Yeah, that's right. I heard of rustlings before. So this version is just like part of an experiment from Brown University where they added some quizzes and some visualizations, but it seems very limited so far. It's pretty much doing the same thing. So we'll see. So anyway, we are just going to add the random crate to our dependencies. We do it by following what they said here. So it's just basically saying anything with a 0.8.5 and 0.8.6 and whatever are all going to be basically considered compatible. But if you change to 0.9, it's no longer compatible. So any of the position changes basically breaks it. Now, without changing any of the code, let's build a project. Okay, let's do that. Cargo build. And now you can see it's like getting the rand crate, and it also compiled it. And the rand crate itself probably had a whole bunch of dependencies. So it got those. And now we have it. Cargo fetches the latest version of everything from a registry, which is a copy of crates.io. It checks the dependencies section, download any crates that aren't already downloaded. Okay, great. If you immediately run cargo build again, you won't get any of that. Yeah, we didn't get any of that. Ensuring reproducible builds with cargo lock file. So it's basically saying the cargo lock file here has like the versions of things that we downloaded, that cargo downloaded for our dependencies, so that they will always be the same when we try to use it. You can check this file into Git, and then your other team members will basically have these exact same versions as you do, and that's useful because then it'll react the same way, right? Like with our dependency, it's pretty like clear that we want exactly 0.8.5, but often in these TOML files you say something like at least or greater than or something like that. So not everyone, when you do cargo build, are going to get the same dependency version numbers. It depends when you do it. Cargo update will pull up a newer version of your dependencies, but in the last 2 minutes, no one has updated the rand package. At least not the 0.8 version of it. Oh, wait, it got 0.6? No. Ours didn't change, probably because they wanted us to use a little like tick mark. Is actually, which means any version that is at least 0.85 but below 0.9.0. Okay. Whoops, I didn't mean that to click on that. We just talked about this. Cargo ignores the 0.90 release. Yeah. You have to update to look like this. So we'll do that. We'll change this to, whoops, 9 and this one to 0. And now if we do, whoops. And now if we do cargo build, it didn't find a match. It's basically saying that didn't like this one. What happened? dependencies rand equals 090 according to a new version you specified. And then it said fail to select a version for the requirement rand equals 09's candidate. Versions found which didn't match 090 beta, beta alpha, required by guessing games. That's us. If you're looking for the pre-release package, needs to be specified explicitly. All right, so this is all theoretical because we're fine with the 8.5 version. Where did you guys go? I lost my chats. Here we go. Cargo log similar to package log.json. I checked, there is not a 090. It is, yeah. Good for checking. All right, let's start using rand to generate random numbers. Okay, so let's do that. Here's our source file. We have to guess the number. And now we're going to choose a secret number here. And we're going to call from the rand crate thread RNG gen range 1 to 100. And they will tell us, of course, what all of that meant. And then we print out the secret number. Print line. The secret number is, and we print out secret number. Notice that this secret number is not mutable because we didn't put we don't have let mute, right? Because the secret number isn't going to change during the life of our program. And secret number is secret number. We can do this because it's just a variable. It's not a calculation. Please input your guess. We already have that line. Guess equals string new. We'd have that. And we have all of this. Yay. Okay, so first we add line use rand RNG. We forgot to do that. Use rand RNG. I typed this in wrong. The RNG trait defines methods that a random number generators implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. I think traits are basically like interfaces. Next, we're adding two lines in the middle. The first is rand thread RNG function that gives us a particular random number generator we're going to use. So this returns something that is a random number generator. Type is that is a random number generator. One that is local to the current thread of execution and is seeded by the operating system. Then we call genRange method on the random number generator. This method is defined by the RNG trait that we brought into scope with use rand RNG statement. The genRange method takes a range expression as an argument and generates a random number in that range. The kind of range expressed we're using here takes the form start ... equal end and is inclusive on the lower and upper bounds. So we need to specify 1 ... equal 100 to request a number between 1 and 100. Yeah, I think the equal means inclusive on the end. Otherwise, it would be 1 to 99, basically. Note, you won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is that running cargo doc open command will build documentation provided by all your dependencies locally and open it in your browser. If you're interested in the functionality in the rand crate, for example, run cargo doc open and click on rand in the sidebar on the left. Wow. You think that actually works? Cargo doc open. So here it's pulling in rand. Yeah, I didn't think it could because I'm running this in a Windows subsystem for Linux, so I don't think it knows how to open up the thing. But I think all of that's online anyway, so it doesn't really matter. The second new line prints the secret number. This is useful for in development. We'll delete it from the final version. Now try running it. The secret number is 38. Let's guess 38. You guessed 38. Great. And obviously I can guess wrong and it won't know any difference because we don't have any actual logic there yet. But we did get different random numbers, so at least we know that part is working. Now that we have user input and a random number, let's compare them. Okay. Note that this code won't compile just yet. That's why this guy's like unhappy. He looks a little stressed, doesn't he? Okay. So under you guessed, here we're going to do match guess dot compare, and we're going to pass it the secret number as a reference. Remember we learned what a reference was? Ordering less, print line too small, ordering greater, print line too big, ordering equal, oops, ordering equal, print line you win. All right. So this obviously, obviously it won't work because they said that it won't work. Yes, he is in stress. We love Ferris. Rust Day. Hey, Satoru, how are you? Well, I don't know, Rust Day. I'm just doing Rust. We may like switch in a bit. Just streaming whatever I feel like, I guess. But we're doing this like version that's from CS Brown where there's some quizzes, but honestly, I'm not seeing many quizzes, so it doesn't seem like it's that helpful. They said that this won't work, so let's see what happens when we compile it. Cargo build. Remember we learned cargo check, right? It won't compile, but it'll give us the errors. There's a lot of errors. Match arm body without braces. Did I type it in wrong? Compare. No, I typed it in. Oh, right. At the end, these are all commas. Okay, so now what is it saying? Failed to resolve use of undeclared type ordering. Consider importing one of these enums. Alright, so basically it doesn't know about ordering. And I'm sure they're going to help us with that in a minute. Expected reference string found reference integer. Alright. Which means that expected string found integer. Interesting. So I guess the string that the secret number is a number inside of Rust. I think I have a syntax error. I think you mean like from before, right? Yeah, now there's no syntax error, I don't think. Alright, so we used we have to add in this comparing order thing here. I didn't see that. Use standard compare ordering. So this is another library to use. The ordering type is another enum and has variants less, greater, and equal. So this compare function, I see. This is basically going to check like which one of these it is, and these are the three different variants of ordering. These are the three outcomes that are possible when you compare two values. When we add 5, then we add 5 new lines at the bottom. The CMP method compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing guess to secret number, and then returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next based on the variant of ordering, which variant of ordering was returned from the call to compare with the values in guess and secret number. Right, so in the end, like this match, that's what this brace and this body is about. Match is going to take these arms basically, and it's going to say, hey, is this whatever this is, which one is it of these? So I can say it's equal to one of those, right? And compare is going to return one of those, so we're basically checking, hey, when compare returns, is it returning less, greater than, or equal to? See you, Jester. Yeah, from before. Yeah, thanks, Satoru. And Ben, we do love the crab for sure. It's almost as good as the gopher, right? No war intended. Then we add the 5 new lines at the bottom that uses the ordering type, the compare method, blah, 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 blah. It returns a variant. We did that. It's made up of arms. An arm consists of a pattern to match against and the code that should be run if the value given to match fits the arm's pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns in the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle all of them. These features will be covered in detail in chapters 6 and 18 respectively. Let's walk through the match example. Say the user had guessed 50 and randomly generated secret number was 38. When it compares 50 to 38, the compare method, right? So here, this guess.compare, our guess was 50. So we're calling 50.compare. And I guess like all integers have this compare method. We're passing 38 here, and compare is going to say 50 is greater than 38, so it's going to return the greater value of this enumeration. And then it's going to look down here and say, this is greater, so too big. It still doesn't compile. Mismatch type, expected string found integer. That's what we saw, right? Yeah. Expected string found integer. The core of the error states that there are mismatched types. Rust has a strong static type system. However, it also has type inference. When we wrote let mute guess equals string new, right, over here, Rust was able to infer that guess should be a string and didn't make us write the type. Yeah, how do you do that again? Isn't it just like string? Is that right? Yeah, I think that's how it works. Rust was able to infer it's a string, and then a secret number, on the other hand, is a number type. So secret number here is a number type. A few of Rust's number types can have a value between 1 and 100, I32, U32, I64, as well as others. Unless otherwise specified, Rust defaults to an I32, which is the type secret number, which is the type of secret number unless you add type information elsewhere that would cause Rust to infer a different numerical type. The reason for this error is that Rust cannot compare a string and a number type. Ultimately, we want to convert the string the program reads as input into a number type so we can compare it numerically to the secret number. We do so by adding this line to the main function body. That's over here. Here's the guess. Here's the read line, the expect, and now we're redefining guess. Let guess, right? We have a new guess here, I guess. Guess.trim, so it's trimming this guess over here, and then it's parsing it, and it says expect, please type a number. Here we go. We create a variable named guess, but wait, didn't the program already have a variable named guess? It does, but helpfully Rust allows us to shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name after name rather than forcing us to create two unique variables such as guess string and guess. What is I32 and U32 if not EAX register? I'm not sure what EAX register means. Is that a joke? I guess. But yeah, signed 32-bit integer is the I32 and U is the unsigned. So that's what that is. Or WX register if on an ARCH64 device. Ah. Yeah, architecture. We create a variable. Yeah, we're shadowing. I hate shadowing. It gives me so many errors because I just forget. I don't realize I'm shadowing, you know, that's the problem. Here we go. 32-bit register on x86. x86-64 assembly. To bind this new variable, we bind this new variable to the expression guess.trim.parse. The guess in the expression refers to the original guess variable. Yeah, so what I was saying is this guess is actually the guess we get here. This guess doesn't really come into play until after this line is done. The trim method on a string is will eliminate any white spaces at the beginning and end, which we must do to be able to compare the string to a U32, which can only contain numerical data. The user must press enter to satisfy read line and input their guess, which adds a new line character to the string. For example, if the user types 5 and presses enter, guess looks like this, 5 \n. The n is a new line. On Windows, it gives you carriage return and new line. The trim method eliminates both of those and you just have 5. The parse method on strings converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number type we want to use. We want by using let guess U32. So here parse knows which one to return, which one to parse into because of this U32, which is an unsigned 32-bit integer, which is a good default choice for a small positive number. How Sorry, I'm just trying to fix this chat thing again. All right. Done. Parse will only work on characters that can be logically be converted into numbers, so they can easily cause errors. For example, if the string contained this, there would be no way to convert that to a number. Because it might fail, the parse method returns a result type. Yeah, so this parse returns a result type which has that OK variant, and it has the error variant. We'll treat this result the same way by using the expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. If parse can successfully convert the string to a number, it will return the OK variant. Alright, so let's try running it again. The secret number is 86. Now if I guess 1, it says too small. It's 57. If I say 90, it says too big. And now if I type in something that's not a number, it says parse error, please type a number, right? That was from our code here where it says expect please type a number. And then if we give it the right number, 91, then it tells me I won. Oh yeah, good point. If we can actually give it like spaces before the number, and it will still work because we call trim, which removes white spaces before and after the number. Allowing multiple guesses with looping. The loop keyword generates an infinite loop. That doesn't sound dangerous at all. We'll add a loop to give users more chances at guessing a number. Okay, so we're adding a loop here. Where should it start looping? Right before we're giving this. And I guess we keep all of this in the loop. Input your guess. We match. And then we close the loop. But now, even when we win, it'll just keep going, right? Rust is awesome. I use it for almost 7 years now and continues to amaze me. So if I do 33, it's too small. If I do whatever, it's too big. But if I do 33, it's, oh, I meant what's the number? 44. You win, but it is gonna I can win multiple times until I press Control C. If the user enters a non-number answer, right, so if I want to quit out of this, I can guess 81, and I say, please input your guess. Done, and then it'll crash. Quitting after a correct guess. Let's program the game to quit when the user wins by adding a break statement. Look at this, we can add a break statement that gets us out of the loop. So we have equal, and now instead of, instead of just having, we need to add brace in here because we're going to do 2 statements instead of just 1. Print line and break. And there we go. I think that's it. Let's try running this. Okay, so 1's too small, 10's too big, 6 is good, and it exits the program because we break out of the loop. And when we break out of the loop, we quit main, and when we quit main, it exits. Seven years of Rust, that's a while. You got on pretty early. We're almost at the end of this. Is that on? All right, let's check about the, for real, I feel like whenever I do a new project and I discover some new nice feature that makes my code 1000% easier to write. Really? You guys will have to help me when it comes to asynchronous code, because I never got to the point where it felt easier to write. It always felt like work. Okay. To further refine the game's behavior rather than crashing the program, let's make it ignore a non-number. So here we go. We basically have OK is fine, but error is we're going to continue the loop. All right, let's try to write that in here. So under parse here, we no longer want this expect, right? And then we have, oh, we need to match. Right, otherwise, so match, and we're matching this, guess, trim, parse. And then the first option is we actually match an OK, and it has a number in it, in which case we return the number. Otherwise, if there's an error of some kind, the underscore means we don't care about what error it is. We're just going to continue. So let's try that out and see how this works. So I put in some number and then I tried saying done. It just keeps going, right? But you would think that wouldn't it be better to like print out something in here? Like print line, please type a number. Oh, please not text or whatever. Please type a number, not text. At least now it kind of tells us that, right? And now if I guess 51, we're done. Okay. So, yeah, I think we already understand all of that. And awesome. With one final tweak, we'll finish the guessing game. Recall that the program is still printing the secret number. That worked well for testing, but it ruins the game. Let's delete it. Oh no, then I won't be able to cheat. I started at the end of 2016. I used the first version of the book. The second version is very different. The one you are using are based on a more recent version of the second edition of the book. In my opinion, Ben says Toka.io is a really good crate for async stuff. Yeah, I've used Toka.io, but like it's tricky because when you have lots of, well, we'll see. We'll see when we get there. Yeah, I would think printing something is better, right? We've built the guessing game. All right, so now we're Rust programmers, right? So what's funny is they didn't they didn't give us any quizzes. Like I went through this whole thing and it said it was going to give me quizzes, but there were no quizzes. So I don't know. I think we will stop here on Rust though. Common programming concepts. Because we did this, we did getting started and programming guessing game. I don't know, did I do that in the last video? I think probably did, so we're not much further, but at least we did this version of it that was based on the quiz, which sounded like a good idea at the time. So you guys want to do something else? Like, do you guys feel like doing any Haskell or Atari Assembly or Nix or Gleam? Or you want to stick to Rust and like do another chapter? I'll let you think while I use the bathroom real quick. I'll be right back. Be right back. Did anyone say anything? Koka. Yeah, I heard that was one of Elixir's influences, which seemed really cool. Um, but it's more of a research language, right? Is that from Microsoft? Yeah, is a research language that is currently under development, not ready for production use. Nevertheless, the language is stable and compiler implements the full specification. There's no async libraries and package management. The core of Koka consists of a small set of well-studied language features like first-class functions, a polymorphic type and effect system, algebraic data types, and effect handlers. Doesn't Haskell have all of these though? Each of these is composable and avoid the addition of special extensions by being as general as possible. Koka tracks the side effects of every function in its type where pure and effectful computations are distinguished. The precise effect typing gives the Koka rock-solid semantics backed by well-studied category theory, which makes Koka particularly easy to reason about for both humans and compilers. And then they have this like reference counting thing without that seems magical. I remember that. So it wants us to use Visual Studio Code, which I hate using. Koka release download. It looks a lot like some Lisp thing or something. Yeah. Ooh, I wonder how hard it is to learn this. Get started. So, Koka. And it gives you Koka and Koka plain. Koka 310. Microsoft Research. So it is the Microsoft one I was thinking of. Interesting. The cause is hidden. The effect is visible to all. Yeah, what is the LSP for Koka called? If you don't use LSP or don't know how to configure your editor, no need to worry about using VS Code. Yeah, it's just that I don't think Helix has Koka in its list of languages that it supports. Oh, it is here. Koka, none. So I wonder which one is the Koka LSP. But maybe it's in the get started. Doesn't say here. Installing the compiler. This is like really hard to read. They made really small font here, right? Okay. This stuff, la 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 la, open samples. Manual installation, Koka. Running the compiler. Koka samples, basic Caesar KK. So it tells you where it created it and then you can run it. Interactive compiler. Oh, wow. Okay. And I guess this tells me the type of something. So that must be a list. I guess we'll have to figure out. Type identifier head cannot be resolved. Can't be too smart about it. Alright, load. Use a tab completion to avoid typing too much. I don't... Does it have the samples in here? I'm guessing that this one doesn't. No. No. What's next? Carrie Fisher. I think of my body as a side effect of my mind.
Oh oui, je vois bien.
The cause ceasing, the effect ceases also. Edward Koch. So awesome. Basic Koka syntax. Browse the library documentation. So I guess basic this. Whoa. Why would I click this instead of just go here? Koka has his LSP coming together with the Koka binary. Yeah, but well, it doesn't really matter. There's some reasons for doing this. But I guess, yeah, I don't really want to be convinced. I just want to try it, right? So maybe we should just go to chapter 3. Koka is a functional-oriented language that separates pure values from side effects computation, giving the importance of effect typing. The name Koka was derived from the Japanese word for effective. Ooh. Koka. Cool, I could read it. Basics. Hello world. As usual, we start with a very simple program, hello world. I guess we can try it in here and see if we can figure out how to compile it. Hello world. And then we save this. And then maybe we can like make a little thing here, projects Koka. And what was it? Koka test dot, is this how you run it? All right. Ah, right. And then it made, what? That is not the easiest way to run something. Seriously. No wonder they want you to use Visual Studio, right? Functions are declared using the fun keyword and anonymous functions with fn. Interesting. They distinguish between the two. Due to brace elision, any indented blocks implicitly get curly braces, and the example can also be written as main. Okay. So this is the same. You want to eat? Yeah, I'll eat just as soon. You want to order something? Why don't you choose? All right, so where are we? Yeah, I mean, that's really obvious, right? Not much to test here, but I guess it's just nice to try stuff. Did it give me the same program? It did, huh? Yeah. Why do you look so pale? Oh, that's not a nice thing to say. It's the light. But I don't go out much. Literally. Here's another short example program that encodes a string using the Caesar cipher, where each lowercase letter in a string is replaced by the letter 3 places up in the alphabet. Alright, well that sounds pretty cool to imagine. Notice that we are not using main anymore. fun encode, it's taking a string, shift int.
Elle est où ma tisane?
Ah, interesting. So inside of this encode, we're now making a function called encode character, which takes in a C. Here we're not telling it what it is. And if C is less than the character A, or if C is greater than Z, then return C. So we're not going to do anything if it's not like a lowercase letter. In Haskell, we would just get the range, right? We would be able to do A dot dot Z, and that would be pretty fast. Val base is equal to C minus A int. So what is this doing? It's basically getting it's translating base to translating base relative to A, the first letter of the lowercase character set. And now we're going to be, what is this, rotating base plus shift modulo, I'm guessing 26. So that's like 26 characters in the alphabet. Broad character plus A. So now we have this this function available to us. We can do smap. What is the difference? What's like smap? So the string, this is this S from our parameter string, has a map function. It's so weird. Like I would expect it to be like map, S, right? But it's smap. I wonder how that works. So each type has an associated function so that you have one that's specific to strings versus integers. Like integer map and string map are different, I'm guessing. I'm having a good day, Shane. Thank you. Encode character, which means we're calling encode character, this function up here, with our and we're iterating in our string. So it's calling each character. So it's going to call each character of our string with encode character. And now we have a specific Caesar version of this, which takes in a string and it returns a string. Notice how these guys declare what they're returning here, but the other function didn't. sencode 3. So this is going to call our encode function here, but with shift being set as 3. Oh, I see. sencode is basically saying it's going to pass string as the first parameter. So really it just means map is like, it's basically calling map, but with string as its first parameter. That makes sense. In this example, we declare a local function, encode car. This is a local function because it's only within the scope of encode. The final statement smap encode char applies the encode car function to each character of the string S, returning a new string where each character is the Caesar encoded. The result of the final statement in the function is also a return value of the function. You generally leave out the explicit return. So this won't actually, this will just print out hello world if I run this, I assume. Same code, right? Yeah. But now we can actually call Caesar and pass in a string, GHI Just feels a little weird, so we'll just stick with one format. And it's shifted it by 3, G, H, I, J, and then H, H, I, J, K, and I, H, I, J, K, L. So we got J, K, L at the bottom here. So that worked. It was on my list too, by the way, like checking out Koka. So how did you hear about Koka? Dot selection. Koka is a functionally oriented language where functions and data form the core of the language in contrast to objects. For example, in particular, the expression s.encode3 does not select the encode method from the string object, right? It just passes string as the first parameter. I figured this out. It was probably really obvious to you all. Similarly, cint converts the character to an integer by calling int c, and both expressions are equivalent. The dot notation is intuitive. You guys see what I see here? It has the double dots on top of the I, intuitive. These guys don't seem like they would make a joke, like do that by accident, right? That's so cute though. The dot notation is intuitive and quite convenient to chain multiple calls together, as in, right, make Rust coloring generic. Fun show at S string, S encode 3, count, print line. So this is similar to Elixir where you have the pipe operator. It takes the first parameter, it takes it and puts it into the first parameter. It takes the result and puts it in the first parameter. And then it gets a little tricky because sometimes functions are written in a way that you don't want it to be passing it in the first parameter. You want it's being passed as like the second or whatever. But it's still super useful. For example, where the body desugars as printline count in code s, 3. Yes. An advantage of the dot notation as syntactic sugar for the function calls is that it is easy to extend the primitive methods of any data type. Just write a new function that takes that type as its first argument. In most object-oriented languages, one would need to add that method to the class definition itself, which is not always possible if such class came as a library, for example. Yeah, it means like I can just add a function that takes string as its first parameter, and now it looks like string has that as part of its library. Type inference. Koka is also strongly typed. It uses a powerful type inference engine to infer most types. Powerful type inference engine. And types generally do not get in the way. Yeah, inference engines are like, generally means that it compiles slowly. So when it's like super powerful, I think immediately like super slow compiling. But yeah, that's cool. I personally like it, I guess. I used to not really enjoy type inferencing as much, but I've come around. In particular, you can always leave out the types of any local variables. This is the case, for example, for base and rot values in the previous example. Hover with the mouse over the example to see types that were inferred by Koka. Generally, it is good practice, though, to write type annotations for function parameters and function results, since it both helps with type inference and it provides useful documentation with better feedback from the compiler. For the encode function, it is actually essential to give the type of the S parameter, since the map function is defined for both list and string types, and the program is ambiguous without an annotation. Yeah, so it's saying that we need to give the parameter here for this encode here. Is that really true? I think in our example, maybe it's not. Ah, it is. Identifier map cannot be resolved. Where does it tell us this? I'm surprised it doesn't tell us. Is this the line number? 4? No, that's not. But it doesn't know what, like, basically it doesn't know what map to call because it doesn't know what encode to call. Except that, like, when you look at how this is being actually used, Caesar is being passed in a string. So, you know, like over here, this has to be a string. It's the only one being used in the code, but I guess that's different. Is it string with a capital S? It's not. Ay. Alright, so that worked. Anonymous functions and trailing lambdas. Koka also allows for anonymous functions expressions using the fn keyword. For example, instead of declaring encode car function, we can also pass it directly to the map function as a function expression. So basically, in this whole map thing, we can pass in function. This is going to be a lambda function. And then it takes the code here. Oops. And I think that's good. All right, we get rid of this. Function, we pass in this. The tab here, the extra indentation means this is all in a new scope. I think that's it. Oh wait, we're not closing the map. We need to close the map here. All right, so that worked. Nothing surprising here, I guess. It is a bit annoying we had to put the final right parentheses after the last brace in the previous example. As a convenience, Koka allows anonymous functions to follow the function call instead. This also is known as trailing lambdas. For example, here is how we can print the numbers 1 through 10. What's going on here? Function for 1, 10, function I, print line I. Ah. So does that mean I could have just like gotten rid of this parentheses? Oh crap, that is so cool. That is so cool. I love this syntax. That's really neat. So let's see if we can figure out how to make this print 1 through 10, right? So the 4, 1, 10, and now we want to pass a lambda function that takes in the number, I guess. So it's like n. And then in here, what do we just print line? N. Now I'm checking. It looks about what they typed. They use I instead of N. And now we will, I assume I can just like call print line here. Print 10. Type warning. Expression has no effect and is unused. Fun, print 10, 4, 1 to 10, fn, print line I. Is there something wrong with keeping Caesar in here? Ah. Yeah, so it prints 1 to 10. We'll have to understand the effect issue it brought up later. It could just be that we can't have multiple statements in a function like this. But I think we've seen it earlier. Yeah, like this. Alright, print 11. This is especially convenient for the while loop since this is not a built-in control flow construct but a regular function. Okay, now I'm confused. Do you see how like this equal sign is like this? And then I see. So variables. So these, wait, is this like, must be mutable? This must be immutable. And maybe this means it's mutable? Note how the first argument to while is in braces instead of the usual parentheses. In Koka, an expression between parentheses is always evaluated before a function call, whereas an expression between braces, suspenders, is suspended and may be never evaluated or more than once, as in our example. They don't quite explain what's going on here, though. Is this real? Like, this won't compile, right? Sacha, are you still there? Do you know if this is real? Because I'm confused by this now. No, so what? How is this a like, I think I'm missing their point here. All right, I'm really not understanding this. It's a regular function. It's not a built-in control flow, but a regular function. Oh, I see. They're not saying, I thought they were saying that while is like, we're just creating this here. No, it comes with, the language comes with a function in its prelude or whatever you want to call it, that's called while. And it takes in a parameter called whatever this is, I is greater than or equal to 0. If it were in parentheses, that would have been evaluated before the function call. So it would mean that it would be like, if it's 10, then it would be like true. And then it would always be true, I assume. So this would always be true. All right, something I'm not quite getting, but at least we know we don't get it, right? With statements. To the best of our knowledge, Koka was the first language to have generalized trailing lambdas. It was also one of the first languages to have dot notation. This was independently developed, but it turns out the D language has a similar feature which predates dot notation. Another novel syntactical feature is the with statement. With the ease of passing a function block as a parameter, these often become nested. Yeah, I know this looks like it's going to be the same as Elixir's with. Function twice, we call this function twice. We're testing twice, 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 print line high. Where high is printed 4 times, because it's twice, I see. So twice basically takes in 2 functions. It takes in a function and calls it twice, right? And then test twice is calling twice, and it's passing in the function twice. I see. This is twice print line high. So this is basically passing print line high as the lambda function. And then this twice is getting passed in this twice as its function. Got it. Let's see if we understand this. Twice, that's this twice here. Function that takes in twice, that's this twice, and this twice takes in a function that is print line. Using the with statement, we can write this more concisely as with twice, print line high. All right, it just means that you don't need to indent. The with statement essentially puts all statements that follow it into an anonymous function block and passes that as the last parameter. So if you do with and then some function stuff, then it's basically has that function e through n, comma, this gets passed in as the last parameter, which is the body. So that works here because this last twice is getting passed in this print line high as its parameter. Moreover, a with statement can also bind a variable parameter as, yeah, this looks like the Elixir one. You have this function and it's basically binding it to this x. Let's see. And this evaluates to having your function and then calling your function with x as its parameter with the body. Wait. Let me make sure I understand this. So it has all the normal functions, and then at the very end, it is calling that same function, but with a lambda function that takes an x and the body. So here's an example with x da 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 da. So now we're basically going to call this function for each, and then for each is going to be passed in a lambda that takes in x. I see. And here's print line is a lambda that takes in x. All right, that makes sense. Once you see it, it makes sense. This is really cool. It's really, really cool language. God, I don't think I can keep going like indefinitely, so we'll stop at 316. As another example, the finally function takes as its first argument a function that is run when exiting the scope, either normally or through an exception. Again, with is a natural fit. With finally, that takes as its first argument a function that is run. Finally, oh, because it's a with, this turns into finally, and it has a lambda function print line. Yeah, you heard about Unison also. That's on my list too. Oh, it's just my head starting to hurt now. So this is being called, this is finally is a function that takes in this lambda function, this thing as a lambda function, right? And it also takes in a lambda function that is this body. I see. Got it. So all it's really doing is basically when it's in here, when it's done with it, it's going to call this exiting. That's what's going to happen. All right. That's pretty nice. Many languages have special built-in support for this kind of pattern, like a defer statement, but in Koka, it is all just function applications with minimal syntactic sugar. Yeah, that makes a lot of sense. This is something to look at again, but I really like this. With handlers, the with statement is especially useful in combination with effect handlers. An effect describes an abstract set of operations whose concrete implementation can be dynamically bound by a handler. Here's an example of an effect handler for emitting messages. Effect fun function emit message string. Declare an abstract operation emit. How it emits is defined dynamically by a handler. Emit a standard greeting. Hello function hello emit. Emit hello world. Emit a standard greeting to the console. Pub fun hello console1 console. With handler, fun emit message, print line message, hello. I see. So here's the with handler. that's basically saying it's implementing or handling this emit abstract function. In this example, the with expression desugars to handler. So this is the handler. Fun emit message. So here's our function. Local function. Print line message. Da 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 da. Lambda function hello. There's our hello, which is this, which has the emit, right? So it's basically setting up for hello to work. Generally, a handler expression takes as its last argument a function block, so it can be used directly with, right? I think they're talking about this, right? Where was it? Generally, a handler expression takes as its last argument a function block, so it can be like, so yeah, I think they're talking about this, right? This could be like a function block. We can leave out the handler keyword for effects that just define one operation like emit, because it's saying like, I guess it can have more than one if it had more than one thing. With val op equals expression. With handler, oh, this is a little hard to see. Val op equals expression. Cool. It just makes it a lot shorter. So we just got rid of this handler thing, pretty much. Intuitively, we can view the handler with fun emit as a statically typed dynamic binding of the function emit over the rest of the scope. That's really cool. So does this work? Effect function emit message string. You're going to try what for advent of code? Koka? So here's the abstract function. Now we're going to make this thing that works with this effect. Right? So we're saying here that we're going to be using this abstract function emit here, but we can't, it doesn't know enough. Since emit isn't defined, we need to define it. So here we're going to call hello, but before calling hello, we're going to set up this handler, this effect handler. So now hello will have this effect handler correctly set up. And so hello console 1, right? Yeah, and that's not from our previous ones. It's not Caesar or print11. So that's really cool. Here, we'll just make sure by adding a little bit more in here. Yeah, awesome. And I think I can remove this handler, right? And do this instead. And this will still work. Yep. And I think this can do multiple. I think I can put this like this also. What I couldn't figure out is, yeah, okay, so that works. So here's my function body now. Well, that's fascinating. New language every day for 24 days. Advent of code. I haven't done Advent of code for a few days. It just takes a while, and I enjoy this stuff so much. I did not expect to look into Koka today. You guys can thank Satoru. So for that, I think we're gonna stop now because I'm gonna eat dinner soon. Hope you guys enjoyed that. If you're on YouTube, then do like and subscribe. If you're on Twitch, please follow. I have a channel on YouTube if you want to look at other videos. And there is a Discord server that should be in the description if you have any questions or want to chat about stuff. I think that's it. How did you guys like Koka? Satoru, you already looked at a lot of this stuff already, I assume, maybe? See you, Ben. What was I gonna do? I was gonna look at something, no? I forget. I'm like so like, my brain is just so short-circuited right now. Koka took a lot out of me. Yeah, it seems pretty cool, right? I remember what I was gonna do. Alright, that's it then. Thanks everyone. Take care. I will see you soon. Hope you guys are staying warm. Bye.